Now we will start with the topic of system testing. So as I told you, like we have different level of testing: component testing, and then comes the integration testing, in which we have two further parts. One is component integration testing, the other is system integration testing. Now the third level of testing is the system testing, and like you can say it's a kind of final, almost you have the final application or final project ready, and then you apply the system testing. In this testing you can actually test all the functional, all the non-functional behaviors. Normally the end-to-end testing is also being done during system testing. So let's focus on the objective of system testing. System testing focuses on the behavior and capabilities of whole system or product, often considering the end-to-end tasks the system can perform and non-functional behavior it exhibits while performing those tasks. So during system testing you can check all the functionalities, all the non-functionalities of the system. And for the system testing, normally you should have the final production environment in which you should do the testing. For example, for component testing, this we can do in the integrated development environment itself. Like when we have the development environment, in the same development environment where we have done our development, we can test the component or the module. But in the case of system testing, you should have the final or the production environment actually, in which the system will be deployed or your project will be deployed. For example, I will give you an example. If you are developing an app for Android phone, then in the final phase or the system testing, you should test that app in Android, on any Android phone itself, with you all the like your mobile network, with your Wi-Fi. In the system testing, we should have the same the environment as it will be in the future for the deployment of that system. So what are the typical objectives of system testing? Reducing the risk. Like just before releasing your project, just before the release of your project, you are reducing the risk. You are doing a system testing and you are pretty confident that your product is ready to be released. Then verifying whether the functional and non-functional behavior of the system are designed and specified. This we will see in more detail about the functional and non-functional behaviors in upcoming topics. But system testing also makes sure that your functional and non-functional behavior are up to the mark. Then validating the system is complete and will work as expected. Building confidence in the quality of the system as a whole. Just before the release, if your system is working fine, then you will be pretty confident, you don't have any risk, and you can release your product. Even you can find some defect while system testing, preventing defect from escaping to higher test level or production. Like after system testing, you will have an acceptance testing that we will see in this video later. And even if you find some defects, you can prevent them, that these defects will not be there in the production. Like for example, when your project is ready, your product is ready, then it will go into the production for the massive production, for the series production. Then over there, as your prototype is working fine, then if you find some defect in the prototype, you will rework on that, remove the defects, and then you will send it to the production. So these are the typical objectives. For certain system, verifying data quality may also be an objective. As with the component testing and integration testing, in some cases automated system regression tests provide confidence that changes have not broken existing feature or end-to-end capabilities. Like as we have discussed during the component integration topic discussion, that you normally do a kind of automation or regression testing, that whenever you change a module, you will test the whole system again. You will automate it, actually will not do it manually, to see if the change in one of the module is either it is affecting the whole system or not. So the same, in some time the system testing, we will also do this kind of testing. System testing often produce information that is used by the stakeholder to make release decisions. This line is very important, that when you have the system testing, at the end of system testing you will have the your report, and based on that report the stakeholders or your customer will decide, yeah, now we can release our product. System testing may also satisfy legal or regularity requirement or standard. Like sometime it is the standard of the country where you are living, that you have to test your product before the release. You have to follow some standards, maybe some energy standards, maybe some other standards of the particular product, some automotive standards, some business standards. So for that you also need testing. So this could also be a goal of system testing. The test environment should ideally correspond to the final target or production environment. This we have already discussed few minutes back, that a test environment in case of system testing should be the final target or the production environment itself. Like you are doing the system testing, actually it's a kind of final testing. So where you should test, what should be the test environment? It should be the final production environment where actually your product will be deployed. So this is the case. Now we will see about test bases during system testing, like what are our resources, or what are our basis of testing, how we will test, from where we will see the requirements, what would be the basis of our testing. So first of all, the system and software requirement specification, sometime we call it in the short, those who are senior or those who are developers, they use a term SRS document. So that is software system and software requirement document. You have the complete requirement, you will see the requirement, and based on that you will do the testing, that I have this requirement. You will run the test case to see if the requirement is fulfilled or not. You don't need a basic code, you don't need a detailed specification that you need in the case of component testing, but here the upper level requirements. Then even risk analysis reports could be the test basis, that before the starting of the development you have pointed out some of the risks, that at the end when the product is developed, in the past we have seen that this kind of product have these risks. So based on that risk analysis report we can do our testing again to make sure that our product is risk free. Then use cases that you have got during the initial meeting of your product owner with the customer, the use cases. Then epics and user stories. Actually this is a very typical you can say agile development term, epic. What is epic? I will try to explain it here. It is not in the scope of ISTQB foundation level, but actually I will explain it very simple words. Epic is, for example, you get a requirement from a customer. It is a very raw requirement. Let's say he can tell you anything, like the power consumption or of this particular module should be this much. Then based on this one line, which is called epic, you drive different user stories. For example, you say that during this temperature the power consumption will be this, during this temperature power consumption will be this, during this temperature power consumption will be this. The customer simply tells you that the power consumption should be this much. Let's say some watts. Let's say we will take an example of 500 watt. That's a random example. A user is saying to you that power consumption of this particular module should be 500 watt. So it's an epic. Based on that you will see that oh, if I have a temperature like it's a minus 10 degrees centigrade, then how much will be the power consumption, then for plus 10 degrees centigrade, then 40 degrees centigrade. So based on that you will make different user stories based on that epic, and it is called user stories. Those who are working in agile development environment, those who are working with Scrum, they know these terms very frequently. It is not this, it is out of scope, but only for the interest of viewers I am explaining it here. Then for the system testing you have test basis, model of system behavior. You have the complete model, how the whole system will behave, a basic overview. You can also use it as test basis. Then state diagram, system and user manuals, everything from the upper level, not in detail but a complete overview of the system. So these are the things which are test basis for our system testing. Now what are our test objects, what we are testing what we are testing in the system testing. So just like a raw idea, we are testing our product, we are testing our application. So what could be the objects which we are testing, what we are testing during system testing? It could be applications which we have developed, different kind of application, maybe web application, mobile applications. Then maybe your hardware or software systems, they are completed, and now you are doing system testing for them. Even some operating system, you have developed a complete operating system, and you can also test it during system testing. Then system under test itself, like you are testing the whole system, so it's also a system, it's a system under test. Then system configuration data you can also test during system testing. What are the typical defects and failures actually which you can face during system testing? This we will see here. Maybe incorrect calculations. There are some incorrect calculations. It is not your calculations for the whole system, the behavior of system is not correct, so it could be a problem. So incorrect calculation could be a typical failure or defect during the system testing. Then incorrect or unexpected system function and non-functional behavior, like the user say that I am expecting this behavior, but when you run the test on the whole system, you are getting some unexpected results. Could be a functional, could be non-functional. So it could be a kind of defect and failure. Then incorrect control or data flows within the system, like the controlling or the data flows within the different modules of the system is not correct. This could be a typical defect and failure. Failure to properly and completely carry out end-to-end functional tasks. Your end-to-end functional tasks are not being performed, like you are giving some input and you are getting some output from the system, but it is not as expected, so end-to-end functional faults could be there. Failure of the system to work properly in the system environment. It is also possible that you have developed your system in a different environment and you have deployed it in a different production environment. So maybe there are some changes in the atmosphere, there are some changing in the other outside parameters, so this could be a failure as well. That for example, you have developed your app, Android app let's say, or iOS app, and then when you deployed it in your iPhone or in your Android phone, then when you connected it with the Wi-Fi, it is giving some problem. Let's say when you have tested it in the actual environment, it is creating some problem, so it could be an issue with the typical defect and failures while system testing. Then failure of the system to work as described in the system and user manual, like the way you have described, you agreed with your customer that this system will behave in this way as per user manual, but it is not behaving, so it is also a typical defect and failure. Now specific approaches and responsibilities that one should take care of during the system testing. System testing should focus on the overall end-to-end behavior of the system as whole, both functional and non-functional. Like it should be end-to-end behavior, like what you input you are giving as per use case, as per requirement, what output you are getting. So it should be the base of the testing. Then all the functional requirements and the non-functional requirements should be also be tested during system testing. Then system testing should use the most appropriate techniques. Like there are different test techniques which we use. Sometimes we use boundary values, sometimes we use class partitioning. These we will discuss in detail in chapter number 4. We will discuss about all the test techniques which are being used during the software testing. So for system testing, you should be sure that which technique you are going to use for the aspects of the system to be tested. For example, decision table may be created to verify whether functional behavior is as described in the business rule. This decision table we will also see in chapter number 4, which is a test technique which is being used, in which we use some true false of combination, like truth table, that my functional behavior, if I am giving this input true, this input as false, high or low, so what output I am getting. It's the kind of decision table. So system testing is typically carried out by independent tester who rely heavily on the specifications. It is highly recommended for system testing you should have a separate team. Actually it's a good practice to have a separate testing team, not only for the integration testing but also sometime for the component testing in the agile environment. But for system testing it is it's highly recommended, and normally it is carried out by a independent tester who hasn't developed any system. He reads the specifications, he apply the test technique, and he applies some input and gets some output. So he is not aware of the system, how is it working, but he only tests the system. Defects in specification, e.g. missing user stories, incorrect stated business requirement, can lead to a lack of understanding of or disagreement about expected system behavior. like there could be some defects in the specifications. So when the independent tester will test it, he will maybe also will tell some defects in the specifications as well. Such situation can cause false positive and false negative. This we have already discussed during chapter number 1, what is false positive, what is false negative, which waste time and reduce defect detection effectiveness respectively. Early involvement of tester in user story refinement or static testing activities such as reviews help to reduce the incidence of such situations. So they are saying, for example, you have defect in the specification and the tester is doing system testing. He points out some defect in the specifications. So it's a problem actually, because there is a concept of early testing. Involve the tester as soon as possible. As soon as you have some user stories from your customer, you should involve the tester from the start, from the very start. That then he should tell you that this specification looks wrong, so that you can do some reviews on that. So this was everything from the system testing. Now we will jump to the acceptance testing, which is, you can say, a subtype of system testing. Like in system testing you test the whole system, but you test it by your own. In the acceptance testing, actually you do it in the front of customer. He will then, as the name suggests, it's the acceptance testing. Either he will accept it or not. So now we will jump to the acceptance testing.